addition, he also qualified for FBLA Nationals, and he was a two-time NAC qualified. So really great math guy. In addition to that, he also loves cubing, so Rubik's cubes, which are like really hard and really awesome too. So yeah.
Now I'm going to introduce my other co-host, Alone. Alone is a four-time Emmy qualifier. He represented Washington State at Math Counts Nationals, and he also plays the snare drum for the school marching band. So he's also a very cool guy.
All right, let's get started now. You want to take first question, Leo?
Yeah, sure. So the first question is, um, a cube has a face with area 45. What is the surface area of the cube? So, firstly, we need to draw a cube's face. And if we draw a cube, notice that it has 6 sides. And every side's area is exactly the same. And if every side has an area of 45, the surface area of the cube would just be 45. Oh, yeah. Nathan said 6 faces, so 45 times 6, which is 270. And I think that's absolutely correct because 45 times 6 is just 270. So that would be the surface area of the cube. And checking the answer, that is indeed correct.
Oh, let's go. Awesome. Perfect. All right. Now, for my questions, problem 7. Wow. Long paragraph questions. Okay, let's start reading this. So, Sarah is operating a merry-go-round that can seat at most 15 people per session. There are a total of 80 people in line for Sarah's ride, but everyone in line is paired with a friend with whom they must ride the merry-go-round. All right, all right. For each ride session, Sarah will seat as many people as possible. Assuming that Sarah operates as few ride sessions as possible to save money, okay, sensible. How many total empty seats will Sarah have had after everyone in the line has ridden the merry-go-round? All right, so we see here that Sarah can only seat 15 people per session, so 15 people. The issue we have here, though, is that every person has someone else they want to be with, right? They're really good friends, right? And since there are two people in a pair, right? No, a pair is literally two people. That means there must be one empty seat per session. Why? Because 15 is odd, and that means that we can have seven pairs, which means 14 people, people, and that adds one empty seat. So for every session, you have one empty seat. And since there are 80 people in total, 80 people, and in each session, 14 people, right? 14 people go. So that means that there's going to be 80 over 14 sessions in total. And I think you can reduce that to 40 over 7. Or 40 over 7 should be 5 and 5/7. So what that means is we essentially have 6 whole sessions, right? Because the last session will have like a bunch of empty seats actually, right? So that means we have 6 total sessions. And each session, again, has 15 seats. So 6 times 15 is the number of seats in total, right? And so that would be 90 seats in total. And since we have 80 people, there are 90 minus 80, or 10 empty seats. So I think the answer should be 10. All right, let's see this. All right, the answer is 10. Perfect.
Great job. Now, for the next question, we'll be talking about this is sprint round number 8. And it says, in a list of 8 positive whole numbers, each number is either a 1, 2, 3, or 4. This list has the following properties. The number 4 appears more than the number 3. The number 2 appears more times than the number 1. And the number 3 appears exactly twice. What is the smallest possible sum of oh, there's two typos there, it's fine, numbers in the list? So we want to maximize the number of ones and minimize the number of fours, respectively. So we have two threes here, and we know that the number one, so number of ones appears less than the number of twos, and the number of threes appears less than the number of fours. So there has to be at least 3 fours here, satisfy constraint, and then there has to be a one because there has to be at least one number of one, and there's two twos because there's more twos than ones, and I think I'm blocking my hands. And if you look at this, this if you add all these numbers up, that gives us 3 plus 3 is 6, plus 4 is 10, plus 4 is 14, plus 4 is 18. Wait, I mean, yeah, 4 plus 4 is 18, plus 4 is 22, and then plus 5, that'd be 27. So the answer should be 27. Wait, someone's saying 23. The number 4 appears more times than number 3. Oh, wait, some people are saying 27. Let's check the answer. I think this is right. Oh. Um, oh, wait, stop. I added it wrong. Oopsies. Okay, yeah, you're right. It is 23. Yep, and the answer is 23. I added the numbers wrong by accident. Sorry, guys.
Oh man, it's okay. That's fine. But now, let's go on to sprint round number 10. So in this case, we have a 7-day blizzard. Wow. It hits the city of Snowmound. Thankfully, the tireless snow shovelers can model the snowfall as a linear function of the day of the blizzard, as shown in the table. So, these snow shovelers manage to remove 1 centimeter of snow from the ground every day. How many days after the blizzard begins will all the snow be gone? So, the first thing you do in this problem is, because you see centimeters, you have to make sure these units are always consistent. Because in a lot of cases, what they do is they would give you centimeters, and then they'll give you like meters or millimeters or whatever it is. So you have to look through the whole problem and make sure that it's always the same. And in this case, it is. Luckily, you have centimeters here and centimeters here, so we're good. All right, now we have our table and our like linear function. So we can actually figure out how much snow just snows down in total, right? So the first day, there's 2, then there's 3, and there's 4, and so on till 8. And just as Nathan said, we can actually add these up. The way you add these up is using our good old friend Gauss. So we have 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. We gotta pair these up like that, like that, like that, and that's 10 each. So it's 30 plus that 5 in the middle gives you 35. And then in the end, all we gotta do is just say, well, look, they're moving 1 every day, so it should just be 35 as our answer, because they're starting the very first day. I don't know how they're able to like shovel snow in like massive amounts of inches, 35 inches of snow. That's crazy, but we give them the benefit of the doubt. They're able to do it. So the answer would be 35 days or 5 weeks, if you will. So yeah, 35 should be your answer. Oh, yeah. All right, awesome.
Great job. Now moving on to sprint round number 15. Suppose that x and y are real numbers, such that x divided by y plus y divided by x equals 2, and x plus y equals 20. What is the absolute value of x minus y? So the first thing I want to do here is to simplify the algebra a little bit. And if x over y plus y over x equals 2, this also means that x squared plus y squared over, wait, xy equals 2. And because this is the case, this also means that x squared plus y squared equals 2. X squared plus y squared equals 2 times x times y. And notice here that the x minus y squared equals 0 because if you subtract 2xy from both sides, then it becomes x squared minus 2xy plus y squared, and that equals x minus y all squared. So taking the square of both sides, we see that the absolute value of x minus y is just 0. And we didn't even need the value of x plus y. And the answer is indeed 0. So it's a tricky question.
That's such a funny question, actually. Didn't even need most of it, actually. Anyways,
Yeah.
yeah, on to problem 25. So Tina is playing a game in which she starts with 0 points, and on each turn she can either earn 1 or 2 points with equal probability. Okay, what is the probability that immediately after the turn in which she first ends up with a total of at least 4 points, wow, what a mouthful, she has an odd number of total points? Alright, so I think the idea in this question actually is it's basically asking you what is the probability that she skips 4 and goes straight to 5? Why? Imagine this. Imagine that she ends up exactly on 4. In that case, she on that turn that she ended up on 4, that was the turn when like she wait, hold on. Is it immediately after or is it like on the turn? I think it's after. Wait, hold on. Is it like between this turn and the next
Mm,
turn? Yeah, actually no. I think it's on. I think it should be yeah immediately after. So it should be like so you have like turn one, then turn two, then turn three, and then so like immediately after will be like between one and two basically. So it's like after you execute turn one. Is that correct? Is that what you guys got to? I think so. Okay, so in that case, my interpretation works. So it would mean that you basically just don't want to get 4. You want to get 5 and not 4. And in order to get 5, you have to get 3 and then skip 2. So you have to go like plus 2 to get straight to 5, right? Skipping 4 in between. You gotta go straight to 5. Now, in that case, we have to ask ourselves, what is the probability of getting 3? Well, this is how we do it. So she starts with 0, and you have 1, 2, and 3. So here's the idea. 0 is probability 1. So here's what we do. We're gonna make a table. This is gonna be our like the number she's on, right? And then here below we'll have the probability that she ever lands on. Okay? So the probability for 0 is 1. Why? Because she starts on 0. So she will be on 0 no matter what. No matter what happens, she starts on 0. So the probability is 1. It's guaranteed to happen. For 1, on the other hand, there are two possibilities. Either she adds 1 point and goes straight to 1, or she skips 1. So for 1, it would be 1 half. For 2, here is when things get tricky. You might be tempted to say, well, for 2, it's just half, right? Because like the other possibilities are you skip 1. But here's the thing. If you're on 1, you can also go to 2. So in reality, if you are on 1, there is a 1/2 probability that you'll go on 2, because you gotta add 1, right? So in reality, the overall probability for 2 is 1/2 if you start with 0, like if you go from 0 to 2, and then plus 1/2 times 1/2, because you have one probability of getting to 1, and then one probability of going to afterwards. So that'd be 1/2 plus 1/4, or 3/4 in total. Now, for 3, to go to 3, what you want to do is you want to go 1/2 times 1/2, because you gotta like, or actually, no, hold on. Sorry. What you want to do is this. Okay, you have to consider the case where it skips 2, and in that case, it will be basically 1/2 squared, right? 1/2 times 1/2, because you have a half probability of skipping straight to 3, and then you also have to think of the probability of going from 2 to 3, and that would be 3/4 times 1/2. So the first one is 1/4, second one is 3/8, and so overall it should be 5/8. Finally, we're almost done, you guys. 5/8 here. To go from 3 to 5, remember, now this is when things get weird. Like, so far, it's the same pattern, basically, but to go to 5, in reality, what you want to do is you want to skip straight to 5. You don't care about the case where it goes 3 to 4 to 5. You only care about the case where it goes straight to 5. And so that probability would be exactly half of this, because, again, if you go from 3 to 4, you lost. You already lost, like, the game. So you want to go straight from 3 to 5. And so it would be 1/2 times 5/8, or 5/16. And I think 5/16 should be our answer. Okay, it worked. All right.
Great job. The next problem, we have target round number 2. So, two common fractions, each less than 1, have denominators of 6 and 10. What is the smallest possible denominator of the product of these two fractions when the product is written as a common fraction? Okay. So we have two common fractions, denominators. Wait, it's not erasing. Okay. Denominators 6 and 10. So we have something over 6 and something over 10. And we want the smallest possible denominator of the product of these two fractions. Okay. So basically, we want to have something that's divisible by It looks like the answer should just be 2, which is the smallest possible denominator, because we know that the denominator being 1 is impossible, because that means there would have to be at least 1 for both of them, or at least 1 for one of them. So it would have to be 5/6 times 6/10, so we get 1/2. So the answer should just be 2. I think the answer is 2. Let's check to see if it's 2. Oh, oopsies. Huh. That's strange. Oh, okay. So I think the chat's saying that the common fractions have to be in simplest form. So 6/10 is not a common fraction. That makes sense. All right. So instead of 6/10, it should be 3/10 to make it the simplest, because there's no 3's involved here. Because 2/10 will also be not a common yeah, it would have to be 3/10 and 5/6. So it should actually multiply 2. So 5/6 times 3/10. This gives us 1/4. Yeah. And the answer is indeed 4. Thanks for the help, chat.
All right, that was so cool, actually. Really great cooperation there and teamwork. All right, but this is a really awesome problem. It's a geometry problem now. Okay, first geometry problem of the day, I think, right? Yeah. Okay, let's see this. So we have a concave, not convex, interesting, quadrilateral ABCD with a reflex angle of 270 degrees of D. So basically, it's kind of like a 90-degree angle, and then you have like the interior is on this side. It's not on this side. Not on this side. It's on this side. So yeah, and then you have side lengths. AB equals 12, BC equals 2. Okay, yeah, we'll figure that afterwards. So we're gonna just try and draw this. I'm not sure if this is right, but we can always like edit our diagram later on. So we have, yeah, so this is what I'm doing. So the actual quadrilateral is this, but I am going to draw this in over here. And I think Nathan has got the idea for this problem already. So basically, you have like D is that reflex angle over here. And then you have so CD, right? So you have like CD and then AD. They are 4 and 3 respectively. And because this is a right angle, we already know this is 5. However, remember guys that AB is 12 and BC is 13. So we actually know even further this is a right angle. Angle like CAB is a right angle furthermore. Finally, at that point, we can actually really easily find the area of the ABCD because all you gotta do is just find the area of ABC and subtract it from the area of ACD. And that's pretty simple actually because we just have two right triangles. So the first one is 5, 12, 13. So the area is 5 times 12 over 2 or 30. And then the other one is 3, 4, 5. So it's 3 times 4 over 2 or 6. And so overall it's 30 minus 6 or 24. See if we're right. All
Yep,
right, 24.
great job. Moving on to the next problem. This is team round number 2. An airplane has 25 rows of seats, and each row has two groups of 3 seats. Each group of 3 seats has one seat known as the middle seat. Tanya does not want to get a middle seat. What is the maximum number of passengers that could already be in the plane, such that when Tanya boards the plane, she is guaranteed to not have a middle seat? Okay, so let's just draw like one row of seats first. So we have one right here, and there's 25 of these rows. And each row has 3 seats. 3 seats there. So there's total of 150 seats, like the WR said. We want to find the maximum number of passengers that could already be in the plane. He's guaranteed to not sit in the middle seat. So if everyone's already sitting in the middle seat, then she can't sit in the middle seat anymore. And there are 2 middle seats per row. That means someone's saying 149. Not sure this is actually asking though. Is it saying like if there could be configuration where like Tanya does not sit in the middle seat, or is it saying that like no matter what configuration there is, Tanya won't sit in the middle seat? I'm getting very confused right now. So what is the maximum number of passengers that could already be on a plane, such that when Tanya boards wins, she's guaranteed to not have a middle seat? Oh, is I think the maximum number of passengers. Yeah, I think it's 149. Hmm?
Wait, hold on, but um, wait. Oh, I see the issue. Okay.
Wait, so what's the maximum of passengers that could not already be on the plane, such that
Well, yeah, wouldn't it be 149? Maybe they meant minimum? Because that wouldn't make sense otherwise, right? Yeah, wouldn't it be.
well,
Maybe
like,
they
what if
meant
the only
minimum.
seat allowed it left is the middle seat though?
No, yeah, I think it meant minimum. Because if it was minimum, then you could say that, like, um, then what you could say is that, um, because it's minimum instead of maximum, you could say that the just take all the middle seats. So that would be 50 for minimum, but
Yeah,
it's
if it's minimum, it's
maximum
definitely
200.
50,
Yeah,
but
but
it's asking for maximum. So I guess it's 149 then.
true. Okay, let's see. 99.
Wait a second.
Huh?
Wait. 99.
Wait, why is it 25 times 4 minus 1? Wait, why would it be 25 times 4 minus 1? I'm confused.
I'm trying to think. 99 people cannot occupy all the seats except the middle seat.
Oh, wait, I think I get it. Wait, I think I get it. Because I think she can choose which seat to sit in, right? Like, I think she can choose out of the empty seats. And so, what they're saying is that, so there's 100 not middle seats, not middle. And so,
Oh, I
if
see. Yeah, I think I
99 of
see.
those are taken, yeah, so if 99 of those are taken, then she can choose the one that's not taken instead.
Yeah,
So,
yeah, yeah. Okay, yeah, makes sense. That was a
oh,
weird
yeah, but that
question.
doesn't make sense either because they can just take all the middle seats, right?
I think it's like saying there's a ready configuration of the people sitting, and you're saying
Okay,
that
I don't know.
the maximum
It's
number such
I
that
think yeah, it might be that
it's
weird
guaranteed
actually.
not to sit in the middle seat.
Yeah, I don't know. We'll see. Okay. Oh wait, I see what you're saying. Because if it was like 100, then oh yeah, that's true. That's true. That's true. Okay, that makes sense. Yeah,
Yeah.
kind of a weird question. It's okay. All right, let's do this one. This is a cool one. It's team round number 5, by the way. How many arrangements of the letters in the word check contain a palindromic substring, meaning that the substring is the same regardless of whether it's read forwards or backwards, of more than one letter. So, like, usually one letter is palindrome, but we don't want that kind of thing. I think first thing we should do is just list out all these like palindrome things, right? So for two letter ones, we just got CC because if it's two letters, they have to be the same ones, and C is the only one that appears twice. For three, you can have like CHC, CEC, and CKC. And I think that's it because like these two need to be the same. And actually, that concept of like the C's being the only ones that are equal, the only ones that like appear twice, that one's really useful. That concept. Why is it so big? Okay, that concept is just really useful because um, it really restricts the number of palindromes you can have. So yeah, and what that means then is that these four palindromes are the only ones that we can have. So any palindrome we have must contain these. And moreover, what's also really nice about this is that every palindrome that contains this cannot contain any of the other ones. And any palindrome, sorry, any string that contains this as a substring cannot have any of these. Why? Because if it has CC, it can't have H in between, it can't have E in between, it can't have K in between. So what I'm saying is, if you like consider this set of strings that contain each thing, so like the set of strings that contain CC, a set of strings that contain CHC, and so on, all of those sets, we call them disjoint. Disjoint, what it means, here, I'll write it down. Disjoint what it means is they don't have any like common elements. So in other words, if a string contains one of these, it cannot contain any of the others. And that is really useful to us. Why? Because it means we don't have to worry about overlap. So we don't have to worry about like, how like usually you have to like account for like principle of inclusion and exclusion. In this case, we don't care about that because there's no overlap. So all you gotta do is just count for each case, add it up, and we're done. Perfect. Okay, let's do that now. So for CC, first we're going to pick where the CC goes. So you have 1, 2, 3, 4 ways to choose where the CC goes. So that's 4. Afterwards, all you gotta do is rearrange the H, E, and K. And that gives you 3 factorial or 6 ways to do it, or 24 in total. So for CC, we have 24 ways. For the CHC, first thing we do is we pick where to put it. So it's either here, here, or here. Then afterwards, for the other two, we just gotta like, arrange those two. So E and K, we gotta arrange two. So it's 3 ways times 2 ways to rearrange E and K, and that gets you 6. And actually, we have some really nice symmetry here. Why? Because CHC, CEC, and CKC are the same thing, only you're swapping out those. And so in reality, you get C, E, C, C, K, C, and they're also 6, and also 6. So that's 24 plus 6 plus 6 plus 6, which is, I think it's 42 overall. Right? Yeah, 42 is the answer. And yeah, Aditya, Agamya, you're right. Yep, there's only 4 possibilities. And once you figure out the number for each of them, which we just did here, we're done. The answer is 42. All right, awesome, 42.
Great job. Now on to the next question. What is the largest prime divisor of 2425 or 2425? So we can just factor this value. We can see right off the bat that it's divisible by 5. So this is 5 times 485. Yeah, 485. To do the math right. And this is equal to 5 times 5 times 97. So 5 squared times 97. So the largest prime divisor has to just be 97. Let's check this. And yep, it is 97.
Oh my gosh, nice job. Yeah. All right. See this. In a revolution. Oh, this is, by the way, countdown round number 10. In a revolutionary dancing game, Emily can step on an up arrow, a down arrow, a left arrow, or a right arrow. Wow, what a original concept. I've never seen it done everywhere. Like, that's such a new thing. What a great game. It'll be so fun to play. If Emily steps on at one arrow at a time, how many ways can Emily step on the 4 arrows such that she doesn't step on all 4 types of arrows? Okay, so she steps on one arrow at a time, and she wants to step on 4 arrows, but she doesn't want to step on all 4. So you don't want to have all those like up, down, left, and right things. So you have a few ways to do this actually. You can like sort of do all the casework, or you can do what Nathan did. And what he is this. So you have like first you count the number of total ways to do it. So like not including this constraint. And so that would be you have 4 ways, and for each 4 steps, and for each step you have 4 possibilities, and so that's 4 times 4 times 4 times 4, or 4 to the power of 4, or 256. Perfect. Now afterwards, we actually want to count the number of ways that are bad, the ones that Emily doesn't want to do. So she does not want to step on all 4 types of arrows. And for that one would be 24 ways. Why? Because you have 4 factorial ways to rearrange these. If you're going to use all 4 arrows, you're basically just like, permuting. Is that like a verb? Permutationing. I don't know, whatever it is. 4 factorial. Yeah, so that gets you 4 factorial, or 24. And if you subtract these two, you finally get an answer of 232. Yep, 232, check confirms. Okay, and so the answer would be this, hopefully, if we are correct. All right, perfect.
All right, great job. So next question is countdown round number 19. In a geometric sequence of positive numbers, the sum of the first and third terms is 25% greater than the sum of the second and fourth terms. What is the common ratio of the sequence? Express your answer as a common fraction. So we can write that the first term as this, a. The third term would be ar cubed. The second term would be ar squared. And the fourth term would be ar to the power of 4. But notice that the sum of the first and third terms multiplied. I think I'm frozen. Can you still hear me?
No, wait, oh, you're frozen, but I can hear you. Oh, there.
Unfroze now. Okay.
There we go.
So basically the sum of the second and fourth terms is r times the sum of the first and third term. So that means that the common ratio, well, r we know that r, let's take a step back first. We know that 1 over r is going to be 1.25. So that means r is just equal to, well, 1.25 to the 5 over 4, and this equals 4 over 5. So we can check our answer now. And again, yeah. So, yep, and it's 4 over 5.
Awesome. Yeah. All right. Let's do this. Some more strange geometry. Okay. So a rectangle is cut by 3 vertical lines and 4 horizontal lines. We have our beautiful rectangle here, and we have 3 vertical lines, and we obviously also have 4 horizontal lines. 1, 2, 3, and 4. How many rectangles can be made so that all their sides are on the lines or the size of the rectangle, including the original rectangle? There is actually a really nice way to do this. And so the idea is like this. Every rectangle is uniquely determined by a starting point and an ending point on both axes, actually. So for instance, I'll give you an example. If you had, say, this rectangle here, and I don't know, can you guys see this? Like, can you guys see my blue outline of a rectangle? Can you guys see it? Yes. Okay, perfect. Yeah. So this rectangle, it starts here and ends here, and it starts here and it ends here, right? So every rectangle is uniquely determined by that. You just choose the start and the end, and the start and the end, and you're golden. Everything else is just determined from that. Now, it turns out that actually counting this is much easier. Why? Well, let's think of it like this. How many ways are there to choose 2 of these 5 points? Because you have 1, 2, 3, 4, 5 points. So how many ways are there to choose 2 of those? 60? Wait, 5 choose 2. Yeah, 5 choose 2 equals 5 times 4 over 2, or 10. And then for the other one, you got 1, 2, 3, 4, 5, 6 points. And so overall, it's 6 choose 2, or 6 times 5 over 2, which is 15. And so if you multiply 10 and 15, you get your answer of 150, and that should be the number of rectangles there are. Let's check it out. Oh, whoa. Wait. There we go. 150. Awesome. Yeah. Much faster than counting everything one by one, obviously. I think. You know? All right.
Now, let's go on to the next question. Countdown round number 77. In order to earn her black belt, Sarah needs to train for 12 weeks, with each week having 2 classes. Sarah just finished a third of her classes. How many classes does Sarah have left to go before she can earn her black belt? So there's a total of 12 times 2, or 24 classes. And she finished a third of her classes, meaning that she did not finish 2/3 of her classes. And this equals 16, because 24 divided by 3 is 8, and 8 times 2 is just 16. And the answer is 16. Oh, that's it.
Oh, okay. Wait. We done? All right.
Yeah, it's kind
Yeah,
of
okay, we're
fast.
done. Yeah, that was pretty quick, actually. Yeah, that was awesome. All right. Well, thank you all for joining us today. If you liked our session, just feel free to contact us here at this email, support@potion.com, at any time. Also, there's a quick QR code over here for our newsletter. Make sure to join that. There's a lot of really cool resources on this. So awesome to do that. Yeah, if you have any questions, feel free to just drop in the chat relay. We'll just be here for a few more minutes. But if not, live is over, so you can head out if you need to. So yeah, goodbye everyone. Yep. If you have any questions, just put them in chat relay. Oh, Eugene. Yeah, I wonder who appears there. How do you practice? Okay, great question. For math counts, I would recommend to just do a lot of their past tests. Like, so a lot of those problems are honestly somewhat of like a similar, um, like idea, and after some time you eventually just know the format, like, and the general archetypes of problems. And so just, I guess, do a lot of those and eventually just know you have that intuition. But I think in general, if you want to get better at math, preparing for one competition is not the greatest thing ever. Like, try, learning by doing harder problems. But if you want to, like, get better at one competition, just do a lot of problems from that competition, and you'll be able to improve your score for the competition. But again, improving math is obviously the number one priority always. So yeah, how do you
I just
solve?
wanted to
Yes,
say something
yeah.
about this, like the TMA number two question that I was a little confused on earlier. I think I got what it means now. It's trying to say that like if there are like any configuration of some number of passengers, Tanya is always guaranteed to have a non-middle seat. And because there are 100 non oops non-middle seats. In the worst case scenario, that means that 99 of them are filled and she'll still have one seat left. But if there's 100 passengers, then it's possible for the passengers to all fill those 100 non-middle seats, and Tanya will have to be forced to sit in a middle seat, and it's not guaranteed anymore. So yeah, so just 99.
Yeah. And I'm currently replying to, I think it was Ishan's question. And so for estimation, I think general tips for estimation is round to nice numbers. Like, I don't know, if you have like 59, round out to 60, and that's easier, right? And also round one number up and the other one down. And yeah, that's really useful in general. If you have like really, also, okay, I guess for your case, where it's like two different numbers, look at the difference between those two answer choices. And so if it's like a huge difference, like, I don't know, if it's like 10 versus 100, you might actually be able to get away with magnitudes. So, like, for instance, you can say 30 is about 10, and 300 is about 1,000, and then you multiply them up and you get 10,000 as your product or whatever, right? And that's really close to 9,000, which is a real answer, right? And so, so for that, you might be able to use orders of magnitude, which is basically like, the general vicinity of where it is. Is it in like the one digit, two digit, three digit, four digit, seven digit, 10 million digits, whatever it is. You know what I'm saying? It's how many factors of 10 there are. So yeah, if it's a really big variety in the difference. And in general, practice makes perfect. So just do all those things. I recommend trying to do it mentally at first, at least, because it really helps with like forcing yourself to find creative solutions to estimation, and forcing yourself to really like figure out, oh, how can I like compromise here? How can I like get a more tractable equation to solve versus a more accurate, trying to like figure out those trade-offs and all. So yeah. Interesting. Okay. For AMC 8, I recommend just doing past tests again. Do all those past tests and you're good. Because again, if you want to study for so a lot of people ask me, how do you study for this one competition? And I tell them, go do past tests. The better question is, how do I get better at math? And that is, do hard problems. Do problems that are a little over your ability level. You might not get it every time, but if you don't get it, you'll learn from it by writing a solution. So yeah. Amy, again, past tests. I mean, first you have to be at the level of the past test, and that requires doing harder problems, increasing your level, doing books and everything. But if you're at the level, if you just want to get a higher score, if you want to move your score from 7 to 9, or 9 to 11, 11 to 13, you want to do those tests. So yeah. And again, only do this like a month before the test. Don't do it year round. Year round Amy prep does not work. It's a surefire way to hating the test, because who wants to do the same thing over and over again? Anyone? No? Yeah, makes sense. So, yeah, you want to do variety, you want to learn, you want to do hard things. That's what improves you in the end. And in the end, this whole math formation thing, it's not really about the prizes. It's not about scores. It's about learning math, and it's about problem solving. So, yeah. Tutoring. Um, I don't know if I recommend tutors actually. I don't know. I feel like okay, first of all, a lot of them are pretty expensive, which is like a pretty big factor in that. But also, I feel like they don't help so much. Like if they're really good, obviously, then they help. But I think definitely it's possible to get the same thing out of it, like to get the same benefit without a tutor. Like if you're just self motivated and if you just do problems, you'll be fine without a tutor as well. So it's up to you, but I mean, there's definitely plenty of resources out there online. Like I don't know, all sorts of like past Olympiad medalists and Amy qualifiers and whatever it is. Whatever level you want to learn, they will be out there. But I don't know if I recommend it necessarily, but they're out there for sure. Okay, interesting. The hard Kaizio levels in Mario Maker 2. Very interesting analogy. Oh yes, art problem solving. It's a great one-stop shop for hard math problems. Completely true. All right. Anyways, any final questions? If not, then I'll just remind you guys, subscribe to this newsletter. It's really great here. You get all sorts of updates here. And yeah, if you have any questions, email us here. And if not, goodbye everyone.
Bye, everyone.
Again, AIMS 12, do pass tests. They're all in the ups. All in the ups. Yeah, thank you for coming. Thank you all for coming. All right. I think we're going to close this meeting now.